Good morning, all my dear students. We are going to study the new chapter Ionic Equilibrium. In 11th science, that is in previous year, we were going to study the bonds. What about the bonds? The attractive force which hold atoms together to form the bonds. The attractive force which hold atoms together to form the bonds. There are mainly three types of bonds. First one is the ionic bond. Second, covalent bond, and third one is the coordinate bond. What is ionic bond? The bond is formed by complete transfer of electron from one atom to another atom. That is studied in 11th science. For example, NaCl, sodium chloride, is the example of ionic bond. Whenever the ionic bond is breaks up, then it gives the ions. What? Ionic bond is breaks up to gives the ions. That is, positively charged ions are called as cations and negatively charged ions are called as anions. Means to what? The ionic bond breaking, it gives ions. What? It gives ions. So ionic term is obtained from the ionic bond. Likewise, that example NaCl to use the Na plus and Cl minus. This equilibrium term is also studied in previous year, that is 11th science. How? The name of chapter chemical equilibrium can use the equilibrium. So what is the chemical equilibrium? In chemical reactions, generally the chemical reactions, that is reversible reactions, can indicated by double arrow. In that reversible chemical reactions, there are two rates are obtained, that is the forward rate and another is the backward rate. So in chemical equilibrium, the both rates are equal, then that is called as chemical equilibrium. Already that term is also known. Equilibrium is obtained from the chemical equilibrium and ionic term is obtained from the ionic bonds. Means to what? Already these both terms are known to all these students. So in this chapter, ionic equilibrium, what? Ionic equilibrium term, how to obtain? Ionic equilibrium means to what? Ionic equilibrium means to what? The term obtained, established, the term established in between ionized and unionized molecules in solution is called as ionic equilibrium. What? The ionic equilibrium term means what? The term established in between ionized and unionized molecules in solution is called as ionic equilibrium. For example, suppose salt ions in water solution. Any salt, for example NaCl, common salt, whenever this salt is added in a pure solvent water, then by breaking it gives the NaCl and Na plus and Cl minus ions. Whenever that breaks to use the ionized and unionized ions. How? Likewise that in that beakers there are two types of ions can be obtained. So the term can distinguish between these two. Suppose These ions are the unionized, and these ions are the ionized. So both these ionized and unionized can distinguish or separated by the layer. That layer is called as ionic equilibrium. So what is ionic equilibrium? The term established in between ionized and unionized molecule in a solution is called as ionic equilibrium. Likewise, that ionic equilibrium term is clear. After that, see the basic terms which are consulted for the ionic equilibrium. Which terms are consulted for the ionic equilibrium? Basic terms. First, electrolyte. Second one is the non-electrolyte. What is electrolyte? The substance gives ions. The substance gives ions dissolved in aqueous solution. The substance gives ions. The substance gives ions in aqueous solution is called as electrolyte. For example of electrolytes, all acids, bases and salts. All acids, bases and salts are the examples of electrolyte. And what is electrolyte? The substance gives the ions in aqueous solution called as electrolyte. Another term, non-electrolyte. The substance cannot give the ions. The substance cannot gives ions in aqueous solution. It's called as non-electrolyte. Example, any example of compounds can made up by the covalent bonds. Suppose for example, glucose, sugar, etc. All these are the examples of non-electrolyte. Means what? It does not give the ions when are dissolved in aqueous solutions. Then see the types of electrolyte. Types of electrolyte. There are two types of electrolyte. First one is the strong electrolyte and second one is the weak electrolyte. What? Strong electrolyte and weak electrolyte. These two are the types of electrolyte. So what about the strong electrolyte? Strong electrolyte means what? The electrolyte dissociate completely. What? The electrolyte dissociate completely in aqueous solution. Dissociate completely in aqueous solution are called as strong electrolytes. For example, all strong acids, strong bases, strong bases are the examples of strong electrolyte because it dissociates completely whenever dissolved in aqueous solution. Next, weak electrolytes. Contrast of the strong. Weak electrolyte, the electrolyte dissociate partially. The electrolyte dissociate partially. That is small in extent in aqueous solution called as weak electrolyte. Those electrolyte dissociate partially, that is small in extent in aqueous solution are called as the weak electrolyte. And examples of the weak electrolytes are the weak acids, weak bases. What? Weak acids and weak bases are the examples of weak electrolyte. So these are the basic terms which are considered for the ionic equilibrium, electrolyte and non-electrolyte. After that, we are going to the next point, that is concepts of acids and bases. What are the acids and bases? Acids and bases. So first of all, see what are the acids and what are the bases. Acids, by general concept, we demonstrate the acids and bases. According to the general concept, what is acid? General concept: the substances which having sour taste. The substances having sour taste are called as the acids. For example, in routine, in example of this acids by general concepts, that is citric acid, citric acid can obtain in lemons or lemon fruits. Another, tartaric acids, lactic acid in milk, etc. All these are examples of the acids which having the sour taste according to the general concept. And second term, that is base. Base means what? The substances which having bitter taste. The substances which having bitter taste are called as bases. For example, baking powder, washing powder, etc. Baking and washing powder. So this is general concept. According to general concept, we are distinguished acids and base only depending upon that taste. General, common. How? Those substances having sour taste are the acids. That may be tartaric acid, lactic acid, and the substances which having the bitter taste called as base. Common example, baking and washing powder, that is sodium carbonate and sodium bicarbonate. Sodium bicarbonate is baking and sodium carbonate is the washing powders. So this is general concept, but this general concept having some lacunates. We cannot give the scientific reasons behind the general concept. So the new concept are demonstrated, that is called as modern concepts. Modern concepts of acids and base. So which are the modern concepts? Modern concepts of acids and base. Modern concepts. First modern concept was demonstrated by the scientist Arrhenius. So that concept or theory is the Arrhenius theory. Arrhenius theory of acid base. How to demonstrate the scientist acid and base? Arrhenius. This concept, it depends upon aqueous solution. Instead of water, that is universal solvent. This concept depends upon the universal solvent, water. Hence, it is called as water ion concept also. What? This concept depends upon aqueous solution. Aqueous solution. Hence, called as water ion concept. Water ion concept or theory. According to this concept, the acids and base are defined as follows. First, A. Acid. How to define acids? by Arrhenius theory. The scientist Arrhenius demonstrated the acid. The substances can produce hydrogen ions in aqueous solution are called as acids. The substances produces hydrogen ions means what? H plus ions in aqueous solution are called as acids. For example, HCl. When this HCl dissolved in aqueous solution, then it gives the H plus and Cl minus ions. So that the HCl is the acid. Why? Because it produces the hydrogen ions, H plus side. When we dissolve in aqueous solution, it's not water. Another example, H2SO4, sulfuric acid. When dissolved in aqueous solution, it also breaks up to give the 2H plus ions and SO4 minus ions. So both these two examples are of the acids according to the Arrhenius. Why? Because HCl and H2SO4 dissolved in aqueous solution to give the hydrogen ions, produces H plus ions in aqueous. Therefore, both examples are of the acids. Then base. According to Arrhenius, those substances produces hydroxyl ions. Produces hydroxyl ions in aqueous solution are called as bases. For example, NaOH, sodium hydroxide, can dissolve in aqueous solution, AQ, then it produces Na plus OH minus ions. Which is the criteria? The main criteria is to what? Those substances can use the OH, hydroxyl ions are called the base. And this is proved whenever the NaOH can dissolve in aqueous, can produce the OH, therefore NaOH is the base. Another example, NH4OH, ammonium hydroxide, can dissolve in aqueous solution, AQ, can produces NH4 plus and OH minus ions. So this is the Arrhenius concept. Arrhenius. What is the main issue of the Arrhenius? Arrhenius can define both acid and base. But the main criteria for the Arrhenius is the aqueous solution. Without aqueous solution, he cannot explain the acid side base. Therefore, this concept is called as water ion concept. And according to that, acid means to what? Produces H plus ion in aqueous, and bases means to what? Produces hydroxyl ion in aqueous. Without aqueous, not. The aqueous term is must for the Arrhenius. Therefore, it is the water. So, after some times, this theory or concept becomes failure. Why failure? There are some limitations. Which are the limitations? First limitation is that in nature, some compounds like AlCl3, then NH3 can shows the acidic and basic characters. What I can say? There are some substances like AlCl3, NH3 can shows the acidic and basic characters. But the acidic and basic characters of AlCl3 and NH3 cannot be used by the Arrhenius concept whenever dissolved in aqueous solution. How? Suppose AlCl3 can dissolve in water or universal solvent, then it does not use the H plus because it does not contain the H plus ions. So we cannot prove AlCl3 is the acid according to Arrhenius. Such as NH3, ammonia is naturally base. But Arrhenius cannot produces the basic nature of NH3. Why? Whenever NH3 is dissolved in aqueous, cannot produce the hydroxide. Because it does not contain the OH minus ion, then how it gives? So basic nature of NH3 cannot demonstrated the scientist Arrhenius. That's why this theory becomes failed. And new theory was proposed by the scientist. Name of that scientist is the laureate. So all these concepts are seen in 11th. In chemical equilibrium chapters, there are some lines. So which are the acids, base, how to demonstrate by general concepts, and modern concept by Arrhenius, Lorimonostate. So depending upon that, the next concept was demonstrated by two scientists, that is Laureate, Bronsted. So second modern concept, name of that concept